dear Mike, dear friends. I would like to share with you in the next upcoming 20 minutes some ideas how vision can become reality, starting with the history. We have to integrate and to preserve the historical heritage in a very sensitive way. In the present time, we are trying to integrate within the landscape our structures, and for the structural behavior itself, we are trying to integrate the soil-rock interactions. And finally, I would like to spend with you a couple of minutes dealing also with artificial intelligence, as all of you did already before. During my university study, I spent some time in Egypt, and I was responsible as a site engineer for the restoration of historical tomb Angkor in front of the Hatshepsut temple, which was built 600 years before Christ. And what we learned there, and this is an image out of the King Seto's tomb, he was the father of Ramses II, is quite interesting that you see over there the art of manufacturing. And we really try to study carefully this procedure, how they did the different mixtures of mortars and so on, and what have been added in order to understand a little bit better a possible restoration procedure. Learning from the history. It brings me to the formulation of Aristotle, which is one of my favorite philosophers. He said, in every historical phase, new discoveries are made, but however, all the time, it is a stage in an infinite progression. So we have only to believe that also the young generation will progress very well and they will do very well. This brings me to the situation where we should go. And this image, I got it from Reinhold Messner, where we had the chance to design the huge glass roof on his castle years ago. The idea, what stays behind of all of us is we have to keep going. Trying to integrate also the historical, not only knowledge, but also experiences. And I would like to point out that what actually the president this morning said, Professor Markus Hilgert, when he announced the so-called Lucius Fabricius Bridge in Roma. This very interesting bridge has a nice story behind. We call that bridge in Italy not Fabricius Bridge, but the bridge of the 4 chairs, I quattro capi. And the story behind is the following. In the 16th century, the bridge was in a very bad shape. And so they called some experts. In the literature you can read that have been architects, but I believe there have been probably also engineers, the 4 experts. And the 4 experts developed by their own 4 individual solutions. And they couldn't find any common solution in order to maintain the bridge. And finally, the Pope Sixtus V, who had only a very short period of time between 1585 and 1590, only 5 years, so he had to speed up like China and India is doing now. And he came up with the following explanation. And he called the 4 experts and told them, you have to respect the 3 following items. First of all, you have to find a common language. Secondly, you have to bring the 4 solutions in a respectful and modest way together. And third, you have to integrate them. So integration is a huge word, which we always try to do. And as you see over there, a historical bridge, which has been also in a very bad shape a couple of years ago, and we had to upgrade the bridge. And what we did was we cleaned the bridge structures. We tried to clean the arches. They have been full of concrete casted in the past 50 years. And by cleaning the arch structures, we integrated them with some lightweight recycling materials adding some cement and some basalt fibers for the first time, and we have been able finally to upgrade the bridge in a very simple way. Integrating our bridges, footbridges in the landscape is not only a scope, it is also sometimes a very, let's say, interesting communication skill and task. We as an engineer have to serve sometimes in a very modest way, as a modest servant, but on the other hand side, we must be also the enabler of very interesting ideas coming from designers, from architects. This kind of footbridge was actually developed with the idea to create some organic element and to shape that in a way that finally it turns out to be an integral bridge. We have been using the veteran steel box girder. The concrete pavement have been actually directly connected with headed studs to the steel structures and so on, in order to have a structure which is quite simple in their design, but it was nicely integrated in the landscape. The stairways has been used also as integral piers in order to activate finally also the foundation. Another example is the footbridge, bicycle bridge, which have been designed by Krüger, Schubert, Van Dreke from Berlin 15 years ago. This bridge connects actually two pieces of the city of Bolzano-Bozen. On the other hand side, the university, on the left hand side, some residential zones. So the idea behind was to create some nicely shaped bridge made out of steel box girders, and we try to integrate also the soil into the structural behavior, developing actually some integral bridge which certainly has a very interesting structural behavior. Now, the situation with such a bridge is always we have to achieve a certain perfection by reducing as much as possible the volume, the masses, and also some, let's say, additional joints and bearings. By doing so, we have been designing a couple years ago this Herzogsteg in the southern part of Germany. And I would like to underline one very important task, which is the straight collaboration with architects. We need them, and we have to find some idea how to work together in order to integrate the landscape and finally to develop also a bridge structure with very little maintenance. This has been already pointed out before, and the idea behind was to use a double curved shell structure, as Mike was pointing out also yesterday in his presentation. And finally, we try to minimize the reinforcement by controlling the concrete temperature. And this sounds easy, but it is not so an easy task if you really apply it in the way that you limit actually the temperature difference. Finally, we have been using some emission low binder. We had to take into account the slower hardening. The construction process is influenced. The bridge deck have no additional pavements or asphalt. We used some deep hydrophobization promoted by the office Schiesels or Edkat Gehlen from Munich. This is an example how in a simple way such an integral bridge can be inserted within the landscape, and on the other hand side quite simple to finally to maintain this kind of bridges. Now, the air pressure, the passive air pressure have to be taken into account, as it is shown in the following formula as well. I would like to come up with two more, a little bit bigger projects. I was heavily involved in the past 2 decades in the so-called Trans-European Corridor from Helsinki to the island of Valletta, as a corridor line of 9,000 kilometers. There are several important tunnels involved and bridges involved within this corridor, for example, the Fehmarnbelt Tunnel. I personally was involved as a member of a commission in the so-called suspension bridge Stretto of Messina, which I would like to announce only, and I was heavily involved in the design, approval, and finally also in the execution phase of the Brenner Base Tunnel. 2 bigger projects as the footbridges are before what I showed before. This suspension bridge has a total length of 3,600 meters, but the length between the piers are 3,300 meters. We have actually 2 pylons connected by 3 cross beams. We have, as it was already pointed out, the 4 main cables, diameters 124 centimeters, the anchor blocks and the suspended deck with some new deck design, which is still an ongoing task in order to optimize that in terms of wind resistance and so on. The tower is a little bit lower than 400 meters since this was some limit given by some, let's say, some code regulation. The foundation is not so difficult. The design is done by COVID Consult of Denmark. So there are different companies involved in the whole design of this very nice, very important bridge. The suspension bridges on a worldwide level are shown in these slides, but nevertheless, the new bridge, which have been approved on the 8th of August, exactly 2 months ago, has a width of more than 60 meters, containing a railway line and 2 highway lanes actually on both sides, which actually should connect the island of Sicily with the rest of Italy. The other project was the Brenner Base Tunnel. The Brenner Base Tunnel should become the world's longest tunnel with 64 kilometers. It connects actually 2 countries, Austria and Italy, and if you think it, both of them are members of the European community, both of them should have the same Eurocode, but nevertheless the complication was quite heavily. We have 39 kilometers in Austria and 25 in Italy, but only to tell you one single story, we have not been able to shift the maximum, the highest point of the tunnel for the slope in the center of the tunnel, since each country and each government want to have their own water resources. We have not been able to tell the surface water to go directly vertically and then to make the right split to the south and to the north, but nevertheless we have not been able to change that after a couple of years. The story started already in 1987, and I was involved between 1995 and 1996 for the optimization phase. I was responsible for that, and finally 13 years for the design approval and the execution phase for the half of the tunnel. 45 years of realization, 23 years for planning and approval, and probably 22 years for construction. This is our reality. Now, the tunnel has 3 emergency zones with 3 exits in order to subdivide the tunnel in 3 pieces, not longer than 20 kilometers. These are some emergency constraints. 2 main tunnels, 9 meters of diameter, and in the middle some exploratory tunnel with a diameter of 6 meters. The exploratory tunnel has been breaking through exactly 3 weeks ago. on the 18th of September. And you see now we have a continuous situation between the two countries. 50% have been excavated on a mechanical with some type TBMs, and 50% by using cast-in-place methods. For the drill and blast methodology, some explosives are used, and this is still an art. And this kind of art, how to place the explosives in the right way in order to avoid a lot of overbreaks, is not an easy task. It is still a manufacturing task. And on the basis of what I saw there, we tried to develop, on the basis of digital scanning, some methodology, how the internal surface could be scanned, and on the basis of, let's say them, on the basis of historical data, on the basis of geological information which are given on a daily basis, we have been able to develop an algorithm in order to do the prognosis for the next upcoming 3 to 5 meters. In order to place the explosives in the right way. What have been the steps? First of all, we had the geological documentations and informations. We took some digital images by using or laser scan or some LiDARs or some also some mobile camera images. We developed some algorithm on the basis of some probabilistic analysis using statistics, saying, okay, we have enough data, we train them, and then we find out a certain percentage, and this allowed us to optimize the drilling scheme on the basis of the historical data and on the basis of actually the information given by the geologist. So the outcome was finally that we have been able to reduce the maximum overbreaks by 65%. And this has certainly also some positive impact on the structural behavior. It's a shell structure, nothing else. And by using a very simple approach, the calculated homogeneous load could be increased by 33%, but more important is we have been able to reduce the thickness also by 36% by using exactly this specific approach. Now I'm coming to the end. The last task shows us some idea about the integration of artificial intelligence. I'm not an expert. I would like to give you only one small example. We know already this kind of bridge, we saw it before. And a couple years ago, we had the challenge to design, together with two architects, Bachmann and Stifter, this hut up in the Alpine regions of more than 3,000 meters, and we have been responsible for the whole engineering design. But through artificial intelligence, you can combine actually those two issues, the landscape of the Alpine zone with the bridge construction, and if you do so, then it comes out like a combined, I go once back, a combined situation where the very nicely designed bridge has been inserted within the landscape in the snowing Alpine zone. And coming to the conclusion. The engineering vision into reality through integration was my main topic. What did we learn? First of all, we have to be open to different hybrid solutions in terms of structural systems, in terms of materials. Secondly, we have to integrate in a very respectful way historical heritages, historical structures. We should learn from the art of manufacturing what they did in the past, also by using printing and new technologies. Finally, the soil, the rock is there, and so we have to use it as in an integrative way and trying to integrate as much as possible the soil structure situation. And finally, AI can help us to transform some visions into engineering reality. And this brings me now again back to Aristotle, with whom I began, since he said us, if you would understand anything, observe its beginning and its development. Ladies and gentlemen, dear Mike, I would like to thank you so much. You are the inspiring ambassador of the Baukultur. Thank you, and thank all of you.
Thank you very much for so much interesting thoughts we got in your lecture. Would you like to add, to ask something, to comment a thought? We got a nicely summary, yeah, to everything.
Yeah, thank you so much for the very informative presentation. It was really nice. The Messina Bridge, I think, is a project which I think the original idea is from really early, and I think biggest plans were 1930s, but it was never completed because it was so complex and so enormous. What makes you optimistic that this bridge will indeed be finished and will be a success?
Yeah, this is a very important question, a nice question as well. The Messina Bridge actually was firstly initiated by the Italian government in 1969, and the first idea was published in 1981, 44 years ago. In the meantime, and specifically in the past years, the project itself was, let's say, subdivided into different tasks. And the different task has to be not only observed, but also analyzed in a critical and open-minded way by international experts. And this gives me also some, not only the idea, but I'm quite sure that we will be able to construct it. In the meantime, we developed a lot of know-how, how to do it. The art of doing that have been improved a lot. Structural monitoring will be included as well. We are observing also the wind situation and the seismic situation in a very careful way. The soil have been very deeply analyzed, and so I'm quite convinced. And as an engineer, I have to be convinced.
Thank you so much.
There's another question there. Oh, sorry, Mike.
Thank you for your talk, Konrad. My question is, you told us that the Brenner will have taken 45 years to realize. Our structures, if they take so long to realize, risk to be obsolete before they're finished. Do you have an idea on how this could be accelerated?
Matthias, thank you so much. I look with a very respectful way to Switzerland. You have been able to develop a modal split where more than 75% of the heavy trucks are going through Switzerland by train and not anymore over the highways, as it is for the Brenner situation. The only way how to do that is actually that Europe helps us to develop some constraints. And I have to tell you the truth as well. In 2007, we developed together with Karl van Miert, who was at that time the coordinator, the European Trans-European coordinator, the Brenner Corridor Platform. 18 years later, I have to tell you that a lot of progress have been done in the meantime. They collected data. It was worked out, but unfortunately, the individual countries and we, as an individual, are not learning enough in order to shift our mobility from the street to the train. On the other hand side, the wells are completely saturated. And if you go to some holidays trip in Italy, you find the highways completely full. This is the only reason that the young generation, they changed already their mindset. And therefore, I hope that the younger generation is smarter as we are.